Welcome everyone, my name is Dawid Cieślak, and I started my journey in iOS working on simple games in Cocos 2D engine, and that kind of pushed me towards working with animations and user-related stuff in graphic design in general. And today I want to share some concept I found helpful, and maybe it will be the case for you as well. So I can speak from perspective of iOS or just Swift, but this concept is kind of useful on all different platforms, so you can just easily apply the same concept on Android, web, that's your call. So the story is in my free time that I don't have recently a lot. I work on a video application that helps you to create slow motion video just by applying the force on the screen with your finger. So imagine that no controls on the screen, and everything you do to make a slow motion video is just pressing your screen. So soft press means slow or just normal speed of video. When you press hard, let's say video slows down to 50%. And the problem with this thing is that the output, the input I need from force touch needs to be very smooth. And it's very hard to generate. Even if I have a lot of experience doing this, I spend a lot of days working on this application, it's hard for me to create very nice and smooth curve that later might be translated into speed of video. And it's especially impossible for the person who can try application for the first time, even if there is some tutorial or guide showing how to use this application and how to control the speed of video. So I need something that can create my noisy input into something very smooth that I can apply as a speed of video. So another example of kind of the same problem is when you want to control the object, position the object on the screen based on accelerometer. So when I first tried to attempt this problem, to approach this problem, I thought, okay, so if we have just accelerometer giving us values from -1 to 1, we can just multiply this by the size of the screen, and it all will be fine. And that's kind of answer you can get on Stack Overflow as suggested answer. And as you expect, the output you get from such thing is not really very smooth, missing the values changing very fast. In everything it looks a bit glitchy. So what we expect is something much more smooth, giving us this nice animation when I'm moving the phone. I see object smoothly coming from one position to another, and there is no this teleport effect. So to sum up the problem, we have a data set that's not continuous, missing the values, and we cannot predict when this new value will arrive and how this value will be calculated. And on the other hand, we want to have as an output something what might be easily translated into some transformation of view, will be given to us in a steady pace. So let's say that in each tick of every time screen refreshes, I want to have new step I can apply as a transformation on the screen. So we're kind of looking for the magic box that can transform some noisy input into something we can use as an animation, and that needs to be done in real time. So when I was looking for a solution for my problem, my friend showed me a concept called PID Controller. So what's PID Controller? It's a closed feedback loop system, usually used in industrial applications, like to control the speed, pressure, or temperature, and it's implemented in things you use every day, like to control the speed of your car when you kick the pedal, cruise control, Steadicam. Even if you set the temperature on your thermostat, it controls the heating system to reach this temperature in some optimal way. And because of this all sounds like a reason why you probably haven't heard about such thing, there's a question how that can be used as something for me as a mobile developer. So if we consider example of, again, moving the object with accelerometer, actually it doesn't have to be accelerometer. Maybe you can just use any kind of sensor you like. The crucial thing is that it changes, and we cannot predict new values, and we have to react to these new values by moving an object and doing some visual effect. So usually you will see PID controller implemented as single class. So every time you have new value from your sensor, instead of moving the object immediately to the new position, you just set the target value. And PID Controller has its own time loop system, and it will ask you, okay, so what's the current value? And considering the thing that, let's say your target value is 70 and your current position is 20, it will give you a small step, like 22. And gradually, in the same way, we reaching the target value. Of course, there might be a situation when this target value will be never reached because, for example, you control the object with accelerometer and you constantly move your phone, so it's actually never reached. That's completely fine for the system. So how does it look on graph? I want to set the new position for my object. And okay, there are three things that happens in loop. PID Controller asks me what's the current position of object, measures what's the error between given position and the target one, and based on that error on configuration you gave to the PID Controller and what happened in the past, it will give you some intermediate point. So we gradually reaching the target value as the time progresses. If you eventually change your mind and you have new target position, that's absolutely fine. It will be adjusted. And at the end, we end up with something that is more likely to be smooth animation. The gap between values is pretty much small, and we just keep getting them in kind of steady pace. So let's say in each tick of every time the screen refreshes. So we can smoothly move from one position to another, apply animation from one position to another. That's absolutely fine. And that was an example of slowly reaching the target value, but by applying different configurations to PID Controller, you can form any kind of output you like. So you might change how fast you reach the value, the target value, or how significant the overpitch is. So to give you something implemented, just give me 1 second to connect my phone. No. QuickTime. Will it work? But that's a good sign. So, yes, okay. So, on this graph, you can see two things. One in the background is a target value we want to reach, and one in the foreground is interpolated value. Later, we want to use as a base for, let's say, animation. And as you see, when I'm slowly moving my target value, there's not much difference. But when I'm doing it much faster, my target value changes fast, and interpolated one is just more smooth. So what's cool about this solution is that when I'm providing very noisy solution, noisy input, it's nicely filtered out. And there's one problem because I cannot see the bottom of this device. Okay. Okay. So let's move to the phone. Just by changing configuration, I can apply something like overpitch. So I have full control over how this curve, how this interpolated value is created. So that's really helpful when you want to create something like visual value-based animation. And to give you an example how that can be useful, for example, in some parallax effect, the rectangle in the background shows my target position, and I'm moving the phone with using this PID controller, and it nicely interpolates the value. So, how to find this thing and how to implement this thing. So this concept is like 100 years old. So you'll find a lot of technical papers, very technical papers, and a lot of implementations on GitHub. Just my two comments on that. a lot of implementations are based on some industrial use or hardware, so you are more likely to find solution for your Android controlling the motor, for example. And a lot of easy, simple implementations you can see on GitHub might be not time-based, so it's more tricky to use them for animations. They might generate your interpolated value between your current position and your target position. But what you need at one tick is actually only one value generated. So at the moment, I work on an open source project called Pulse. And it has two parts. One of them is pure PID Controller implementations. So I want to create a single file solution with just core implementation that is easy to detach, easy to port to other platforms, so you can just easily take it and implement on Android, Windows Phone, what you like, web. And the other part of this project is the tuning helper, because finding the right configuration for your PID controller is kind of tricky. So it's good to have something that can speed up this process. And coding time. So I have a sample project. OK, so we have some mainstream application for runners. And what it does, it shows my average speed at specific point of time. So let's say that my run was 5 kilometers long. And at the end, my speed was 10 kilometers per hour. When in the middle, it was 15. Pretty much a lot, I think. What happens in code is that we only track slider changes, and we apply the progress value to the view. But from important part, that's all. And what we want to do with this application, there are two things. So first, we want to change using slider to using force touch. So actually, by just pressing the screen, I do the same what slider does at the moment. And the other thing is making this more smooth. So coming to the first part. So we want to take the current touch from the screen. So we're taking the force touch, the first touch. From touches. And we want to create something like normalized force. So we're taking the force from the touch. And because we need percentage value between 0 and 1, we want to divide this by the maximum value we can have. And then we want to just apply this to our view. Just I have to deploy this on my device. Wait. And yes, what happens now is as I'm pressing the screen, this value gets updated in the same way I was using slider. So the problem with this solution is it's hard to get the position you want it to. So I'm just slightly pressing, and the difference is quite significant. So what we want to do now is to find some more smooth way to achieve the same effect. So now we want to experiment with using PID Controller. So coming back to View Controller. So I'm going to use the library I just mentioned you about. And first, we want to create reference to PID Controller. OK. First, we need to set configuration. And in a minute, I will explain why this value. So 1 here and 1 4. We want to initialize PID controller. We already made this. Okay. Configuration we just created. And this is the place when we want to say to PID controller, where's our object at the moment, or what's our progress at the moment. And here we just keep getting updated value. So first we want to keep track of the progress we're getting. So we want to tell what's the current progress to the PID controller. Okay. And here we want to update this value. And update the UI accordingly. So most of things are ready. Now we just want to, instead of setting this progress immediately from slider or force touch, we want to ask PID controller to take over control. So PID controller, new set point is normalized force. And because it's a bit easier to show it also with a slider on presentation, I will replace this code with set point and value. So both from slider and force touch, we will get the same effect. Will it work? And also on simulator. So first with slider. As you see, when I'm changing the value, it's not reached immediately. It takes some time to get to this value, and it just provides a bit nicer, smooth experience. And coming to the device, now as I'm pressing the screen as hard as possible, it also takes some time to reach the desired value. But it's also easier to reach the one I want. For example, I want to find the speed in the middle of the race. And with this, when this value is slowly reached, it's a bit easier. So by controlling this value, we can create something a bit more bumpy. And so as you see now, when I'm setting new target value, there's an overpitch, and new value must be corrected. So you can play with this if your application needs that solution. So coming back to presentation. How to find the configuration for PID controller. So PID controller has its name because of three factors: proportional, integral, and derivative. And to find the right one for your input, you can basically experiment. There are only three values. You can see how it works. We can be pragmatic and find the solution just by trying different values. And the other solution is to use some tool that can make looking for this solution a bit easier. So I will just show you one method. So coming back to code, let's say now we did tuning, so we don't need configuration at the beginning. And we just want to find some place when we want to trigger showing this view with configuration. So let's say for me that might be a shake event. Motion began. If this kind of motion is shake event, I want to show tuning view. We don't have to provide configuration, but we have to provide the kind of range of values you expect. So for me, that's, let's say, from 0 to 1, because I'm setting percentage value. And now, when I trigger, I don't see that thing, shake gesture, I have an extra view that kind of helps me to control all these values of PID Controller. So I can just easily change something and see on graph how it works. So you can see that this function might have too big overpitch for your solution, and easy you can change the function, change the factor, and now it looks a bit better. We still can trim and find something that works for us. So some couple of ideas how you might use it in your application. For example, you create some music app and you want to control the size of elements based on samples you have from microphone. Or you want to control the size of elements based on how hard you press on them. And you might control how you navigate on the map with your accelerometer or gyroscope. So these are kind of ideas of cool things you might introduce in your application if you have a lot of time. So if you have any questions or I can help you using such tool, feel free.
There is some nuisance that I don't see, or maybe the library you mentioned does exactly what I need. But I think any given digital signal processing book would solve your problems in like dozen of Swift lines.
I mean,
at least I see some, at least a couple of really basic mathematical tools to like smoothen the line.
But are they as easy to configure like this?
Yeah, I think
Okay.
low pass filter. Haven't tried that.
Oh, I haven't.
Okay.
So, okay, but I will be happy to try and talk to you later. So, yeah, definitely a good idea.
Okay.
Okay, we've seen also on your demo that the animations slow down a bit, I think.
Yeah.
So how computational?
That I would say that would be rather a bug. So I think that should work. So it doesn't take any big computing power. So I think that's just a bug that can be fixed easily. Okay, thank you very much.